The first main problem of calculus that we can answer with calculus was how do we find the slope at one specific point? So we used the derivative for that. And we found the equation, and then we were allowed to plug in a specific x value and find the slope, or maybe an x and a y if it was implicit. So we were ending up with numerical values that actually gave me a slope. What integration does, and this is the second main problem of calculus, is how do I calculate area under a curve? Okay, this is a significant concept that you have not dealt with before. Okay, up to this point, we've done a lot of geometry, right? You took an entire year of geometry, but you haven't really talked about how do you find area under a curve. So we're going to use integration to help us answer that, and it's the idea of using some of the information that we know about integration, right? And then we're going to basically kind of manipulate that, and it's going to give us a numerical answer, kind of like when we plugged in a value for a derivative, we were able to get a numerical slope. So that's what we're building to. Let's talk first about properties. We've been talking about indefinite integrals, the idea of getting an equation where we had a plus c on the end. Now we're going to talk about definite integrals. Definite integrals is the idea of the area between this piece and this piece. So you're always going to have these values here from end to end. This is your left bound and your right bound. So if you're going to integrate from A to A, basically what you're saying is there's no width. So that area is going to be 0 because A and A are obviously equal to one another. So remember, these represent bounds, okay, left and right. So if we integrate from B to A, we can also flip that around and go from A to B as long as we make it negative. Now that is going to come into play quite a bit. So I want you to be really, really careful with that one. We have a coefficient experience as well. We can always take that k out. And again, we can integrate from A to B. We can integrate f of x dx. And if c lies between A and B, so if there is some value, right? So if I'm going from 1 to 7 and I want to go, c is 5, right? That's that idea. We can actually split up the integral into two pieces. So we're going to say that the integral from A to B could be the integral from A to C plus the integral from C to B. So we're going to break that up into pieces. And then you also have your sum and difference that hopefully this is not news to you, that you can actually split across addition and subtraction, and you can evaluate these definite integrals separately. Right? And then, of course, you can do the same thing on subtraction. So we can evaluate from A to B f of x dx. Always got to have that dx in there, minus the integral from A to B of g of x dx. Now, once again, I'm going to re-emphasize the fact that you cannot break things up across a product and a quotient, across multiplication and division, right? So it's really, really important that you recognize this piece, sorry about that, that you recognize that we have no quotient rule, we have no product rule, and we're not going to be able to just split it up into two different integrals. The only time we're going to do that is when we have addition and subtraction. We can also take out a coefficient, but that's about it. Okay, so these are our basic properties that we need to be aware of. So do not do this product thing. Okay, don't do this. All right, it's very, very important.